All right, so the last video left off with a typo, so I fixed it, so here we go. So it's sine of n plus 1/2 pi. So when I plug in n equal 1, I get sine of 3/2 pi. If I plug in n equal 2, I get sine of 5/2 pi. So we know that sine of 3 pi over 2 is -1. We know that sine of 5 pi over 2 gives me sine of pi over 2. That's 1. And it keeps doing that. So this is another one of those stealth ones. You need to recognize it. You need to memorize it, right? So this is exactly the same thing as saying -1 to the n. And then you have this, n equal 1 to infinity. Okay, so now you recognize, oh, it's an alternating series. Yes, it is alternating. I can use the AST. Does it look like the positive terms are decreasing? That these terms of 1 over root n plus 3, as n's are getting larger, do they look like they'd be getting smaller? Check. If I take the limit as n goes to infinity of this, using highest powers, I get 1 over infinity, right? So that gives me 0. So then I can say that this thing converges by AST. All right, let's look at this one. Nth root. I'm not sure. Wait a minute. You've done so many of these. I'm not even going to do AST. I'm going to say, you know what? If I go to the limit, so thinking about the second part of AST. So if you had started AST, that would have been fine. You could have said, I'm doing AST. Looks like the terms are decreasing. Check. And then when you went to go do the limit, as n goes to infinity, I'm going to rewrite this as the exponent that it is. When I put in infinity here, I get 1 over infinity, which is 0. So I get 2 to the 0. So that gives me, that's not 0. So what do I get? Conclusion. You get conclusion that this series diverges, whoops, 2, not n there, diverges by, not AST, T4D, right? So it's T4D. You never say diverge by AST, because it doesn't ever give you that result. And you never say converge by T4D. Okay, and so then we move on to this, which is in the next video.